If you encode with FFmpeg on AWS, you probably know that you have 3 CPU options: AMD, Graviton, and Intel. Which delivers the most bang for the buck? Like most things in streaming video live, it depends. We are here to ask the hard questions like, it depends on what? Hey, John, I have many questions for you today. And here is the question number 1. What criteria were used to select the specific AWS instances for testing, and why were 8-core instances chosen?
In terms of criteria, I used the latest available CPUs from AMD, Intel, and AWS, which is the Graviton series. And I used 8-core because I found that 2-core and 4-core sometimes got unstable when I was encoding the 4K files that were part of the test suite. And I didn't want to go beyond 8 because then the testing would get really cumbersome. To test 8 with the 1080p x.264 file, I was encoding 12 to 16 simultaneous instances. So if I went up to 16 core or 32 core, I would have had to expand that even further. So 8 core just seemed like a really good starting point to run these tests.
Were there any noticeable differences in the overall stability or reliability of the tested CPUs during the encoding process?
Not between the different CPUs. As I mentioned a moment ago, when I ran some of the low core count with low memory instances, I had very severe results if I tried to encode a 4K file. If I pushed the memory on the system, I actually lost the ability to drive them from AWS. I had to basically start over. The machine got so corrupted that I couldn't use it for additional tests. So I recommend not encoding with FFmpeg very large files that exceed the memory constraints of the machine you're on, but I can't say that that was CPU specific.
Can you provide insights into the potential trade-offs between encoding speed and output quality when using different CPUs and presets?
Okay, in terms of output quality, I didn't see much output quality difference at all. So, one of the things I did with all the CPUs was test the output quality with VMAF, and the scores were virtually identical. So quality difference, didn't see anything. In terms of efficiency, I ran 3 sets of tests: 1080p with x.264, 1080p with x.265, and 4K with x.265 using a 10-bit file. And in the first case, I found about a 50% difference between the most efficient and the least efficient processor as it related to x.264 1080p encoding. Specifically, I found that the Graviton was able to produce at about 61 cents per hour as compared to Intel, which was 91 cents per hour. In terms of x.265 1080p 30, I found about a 57% difference between the highest and the lowest cost approach. And highest cost approach here was Graviton. Graviton did not do well with x.265 using the preset that I used, which was a very high quality preset, while AMD proved most efficient for x.265 in both the 1080p and the 4K case. So to finish the numbers, AMD was 549 per hour and Graviton was 863 per hour. And then looking at the 4K 10-bit case, Graviton was $35 an hour, while AMD was $15 an hour. So it was over 100% difference if you're using the wrong CPU from a cost perspective. But quality no, cost yes.
Were there any unexpected factors or limitations that influence the testing process or results?
Number one, the memory issue I talked about before. Don't exceed the memory of FFmpeg, or don't exceed the memory of the machine you're working on with FFmpeg, because it could have very, very disastrous results. Number two, we used different builds of FFmpeg that were optimized for each of the CPUs. And I would recommend that if you're doing benchmarking or even production. So we got these from a website that is referenced in the article that we're talking about, and you can get a link there. But we tested different versions of FFmpeg for all 3 of the processors that we used. The other thing that I found that was really quite interesting was that I saw very little drop in overall efficiency by adding instances. So with 1080p x.264 encoding, you could go 12 or 14 or 16 instances without seeing any loss of efficiency. I mean, you would assume that at some point Ubuntu or FFmpeg would start to increase the cycles to just control the multiple encodes. And I found that that wasn't the case. So the encoding speed overall per minute really didn't drop much if you went from, anywhere from 2 simultaneous encodes to 16 simultaneous encodes. Now, of course, the encodes took longer, but the frames per minute produced was pretty consistent.
Did you consider factors such as power consumption or heat generation when evaluating the CPU's performance for FFmpeg encoding?
I didn't, but one of the benefits that AWS puts out there for the Graviton is that they're much more efficient from a power standpoint than the other 2 CPUs.
Have you considered or tested the impact of using different input file formats or codecs on the performance and cost effectiveness of the CPUs?
I tested 3 cases, x.264 at 1080p, x.265 at 1080p, and x.265 at 4K 10-bit. And again, I found pretty dramatic differences. With the x.264, Graviton was fastest by a long shot, but really dropped off in x.265 encoding when you use the high quality presets that I was using. This is VOD, so in almost all cases, it makes sense to use the high quality preset rather than a fast preset. And once I started going into x.265, AMD proved more efficient than not only Graviton, but Intel, in all cases. Part of that was the fact that Intel, I did my analysis on a cost per minute basis. Part of the difference was that Intel is just more expensive. I think it's about 10% more expensive than the AMD chips, and much more expensive than the Graviton chips. So part of the difference between AMD and Intel with x.265 related to the pricing difference, and a smaller portion related to the actual performance difference.
Are there any specific software optimization or configuration settings that can further enhance FFmpeg encoding performance on AWS?
So I've already talked about using CPU-specific builds of FFmpeg. I didn't see anything else that was AWS specific. There were a couple of things that I tested. All this testing was for a talk I gave at NAB, and I found that you could really shave encoding time without reducing quality if you reduce the number of reference frames. So the high quality preset I was using for both x.264 and x.265 used anywhere between 5 and 8 reference frames. And I found if I dropped the number of reference frames down to 1, the quality difference was minuscule, but the encoding time savings was very significant. Now you can achieve that whether you're encoding on AWS or encoding on any local workstation. So it's not AWS specific, but it was an interesting finding from the testing I did for that talk.
Based on your findings, what are the potential cost savings or performance improvements that organizations or individuals can achieve by selecting the most suitable CPU for their FFmpeg encoding needs?
So as I talked about, I tested 3 cases with 1080p x.264. I saw about a 50% difference between the most expensive CPU, which in that case was Intel, and the least expensive, which was Graviton. With x.265 1080p, I saw that Graviton was the most expensive, and the difference there between the highest and the low was around 60%, and AMD was the most efficient. And AMD was also the most efficient with the 4K 10-bit encode, and the difference there between the Graviton and the AMD was about 126%. It was almost, it was more than twice as expensive to encode with Graviton than with AMD using x.265 and a 4K file. And Intel was always kind of in the middle, never got, was a lot closer to AMD than to Graviton in the x.265 cases, but was always was always behind, was never the first.